Okay. So, as already Dr. Rane briefed about my past over experience and everything like experience and my education and everything. So basically, I'm my full-time core mechanical engineering, but industry demands are we need to be the interdisciplinary attitude always. So by keeping that in mind, currently pursuing uh, handling mechanical activities in power defense and uh, which includes interdisciplinary approach with respect to optical, optomechanical, optronics, or optical plus electronics, and that's it. So the major project which we have carried out by my side, those are uh, SSA, which is INS Anvesh needs the ancillary power unit for running all their units. So my role it was to deliver that same whole project. So, in terms of the mechanical enclosure manufacturing, designing, development with respect to, as it was completely development oriented projects. So, first of all, means hope so. This will be the interactive session instead of just one ended conversation. Hope so. Everyone is getting it. May I have a feedback? Verbal.
Yes, sir.
Hello.
Right now they all are muted, so let me change the settings. Yeah, now they can speak.
Okay. Because in this session, what our actual ultimate objectives are keeps presently the organization the paras defense is not means not allowing us to share the exact details of in details with related to projects and everything which we are dealing with, but apart from that the ultimate objective which we need to form and which is like ki, we should be on same page first of all because you all are from academically background as well as some industrial exposure as well, but at present while working and while studying in during my uh, years of learning, it was something like we were on very drastically on different page. Means we were very theoretical instead of the practical. So I just wanted to means to the loser means the losing up and warm up. Just wanted to understand why we are keeping this. Means we are session after like around like 6 p.m. or something after working hours. May I know any specific reason or due to the availability of everyone?
No, so there are the two important things over here. This FDP has been sponsored by AICT,
Mm-hmm.
and they are conducting the FDPs in two ways. One is offline and one is online. So
Okay.
they have given the guidelines for conducting the FDPs offline in the daytime, and in the for online they are suggested that you should conduct after the working hours. That's the thing. So that's why we are following that.
Okay, it was just random question. But my next question, because I want something interactive session with respect to because even I need the feedback from your on. Hope so. Everyone is from computer science department only, or apart from that, any other
No,
team members are also there.
the participants are from various backgrounds. You can
Okay,
see like electronics guys, mechanical, computer, ENTC, everyone you can see.
okay. But what we are sticking up to the mostly in the AI computer science core domain and its application into space system. Hope so.
Yeah.
Everyone is aware of that.
Yes.
Okay, thank you. So let me start with it. I already gave my brief introduction as we will, but it is like the we'll start with giving the present scenario. What exactly the AI means AI in uh, space mission, AI enhanced space missions, which are like uh, I'll share.
We can see your presentation, but the slides are not changing. Now we can see the change.
Now it is changing. Yes. So this is the basic tentative outline which we are will be going ahead with. So first will already which is done, which is introduction, our introduction, but with respect to the AI implementation in space exploration as well as the complete space exploration and its project execution related to the same. So it's like presently intelligence is transforming the space industry by enhancing mission efficiency, accuracy, and its decision making. Something like tentative key applications which we are currently already we are into domestically as well as globally, which are spacecraft health monitoring, which is AI powered system monitor spacecraft performance, predict potential failures to obtain the preventive maintenance and schedule the same. And according to that, we can actually optimize the maintenance whole. Afterwards, autonomous navigation and autonomous decision making while actual execution of project. So for navigation, which we are usually previously we were means globally we were using something like AutoNav, Lunar Node 1, StarFox, but presently the software which we are stick to the AutoNav and StarFox. So specifically afterwards the next potential application which is like remote sensing, the all parameters which are there, uh, everything, the natural parameters, afterwards the like fuzzy parameters and everything which we are sensing using this same software or some other algorithms. Present after that, the benefits are using AI in space domain, space exploration domain. It is improved efficiency relatively the local because everyone needed like every space mission previously we used to needed one uh, space shuttle and everything. But while looking at the present scenario, many more load is taken by the AI by understanding the needs and everything. But AI is not replacing the actual human factor, which is like intuitiveness. That is needed by human side only. But apart from that, efficiency is improved, relatively enhanced accuracy, and relatively safety is majorly improved in the space of space domain. But potential challenges which we are currently facing, these are like data management. But data management related to the data gathering, afterwards the sensing the data, afterwards the conducting the data in terms of one point to second point with huge amount of time, that modification, after that the computational resources to handle the all the data as well as the remitting the actual, therefore there are much latency in the communication. So, and potential future direction which we are expecting is like edge AI. First of all, to avoid the latency in data gathering as well as giving feedback while execution, we'll be trying to be focusing as it is just theoretical and verbal, but we are actually, I mean, in globally, but we are standing at that position. We are deploying at the edge of network closer to the source of data to reduce latency as well as improve real-time decision making for autonomous decision making as well. So hope so everyone is getting just into brief introduction about this space or this presentation and session. So further, yes, is anyone?
No, sir. Go
Okay,
ahead.
yes. So basically, as you can see, is the present by looking at our present industrial insights, we are standing at that position we are directly implement actually we are in development stage, but we are not, as AI is the connector between the whole technology and the task. So we are, as an industrial insight, what we are facing and what we are seeing is that we are directly implementing the foolproof implemented, first of all, tech and its work which we are facing. It's like integration with our facilities, with our hardware, that is becoming more challenging. So it's like if you are saying the overview of AI space missions, it's like it is very uh, theoretical, philosophical, which we are deriving into. If you'll see the research paper, if you'll see the 10 literatures, if you find out, 8 literatures are more related to the theory and philosophy based, not exactly the implementation, and it is just the overview or summary of the literature reviews or whole articles. But it's like we are handling presently as a paras defense, we are handling very particular scope of work which is related to the optical optronics related. These two we are dealing with. So next slide, which will be going to, it's like a importance. Why actually it is importance of intelligent space system? Because as we have already discussed, it is enhanced autonomy, improved decision making, and cost efficiency. Reliability is getting better and better because of the AI inclusion in the space exploration or space enhanced means AI enhanced space missions. So after we move ahead with the uh, related to the importance detail, which is like spacecraft health monitoring, which we have mentioned the first point. The first point, which is like the spacecraft will be needing the preventive as well as breakdown maintenance as well, but we can't actually uh, at simulation stage we can actually see and bear the breakdown maintenance, but not exactly at actual execution. Well, so preventive maintenance, so individual component hysteresis, individual component health, and everything which we need to monitor with the help of using AI by analyzing few atmospheric parameter as well as some interlogical means if you can see while using we were using uh, some AI for some space program which was for solar powered MPPT algorithm. It is solar powered MPPT algorithm. It's like the equipment was powered by the solar energy, and for gaining maximum output from that algorithm or from which we have developed algorithm for the harnessing the maximum energy by understanding the nonlinear parameters by using AI. It's like MPPT means maximum power point tracking. It is a correlation between current as well as voltage by tuning in particular set of directions so that we can have maximum power output. So that's why that becomes into health monitoring because the gaining energy, consuming it, uh, proper energy transformer and transfusion. We need to understand everything because while transfusing energy from the battery source and while into the actual uh, application oriented, there is so much lag in terms of the losses due to the harmonics and many other factors. So this is the health monitoring, which is important, which we are gaining advantage due to the AI. Afterwards is autonomous navigation system. Uh, Autonomous nature, which we are expecting in two specific domains, majorly, which one is the navigation, which is setting trajectories and challenges remote navigation, afterward intergalactic communication by using many things. But second part is very crucial, which is like when we are need to use when we were not using the autonomous like decision making while executing the projects due to the lag between the data communication, which was like while these mass over project, it was related to in theory by looking after the literature and the past case studies and interviews. They were mentioning around like 18 to 21.5 minutes lag while sending and while receiving. Means you can multiply a rough average by 20 plus 20, 40 minutes. Means literally in 40 minutes over there, the situation will be like way more different because data gathering, data computation, and then execution, then feedback, and this required lots of tedious tasks, which we need to improve. That's why to cut off this whole funda, we have to create like automated autonomous decision making at the age of the application only. The next thing, the parameters which will be needing data, the temperature, the surface roughness, and many more other factor which we need to actually execute the space missions. the parameters, the actual multiple parameters with multiple frequencies we need to gather physically by using sensors. We can't actually. It is interrelated parameters which we need to compute as well and gain the data and then process it. Again, the main thing which we need to understand, it is like the remote sensing of the advanced imaging techniques. Previously, we were while using the high density, more spectral cameras, we were using which were requiring huge cost. But due to using of AI, we can use a relatively lower grade of optical lenses, which we can sustain at that intense temperatures at minus side as well as positive sides. That we can actually the gaining advantage due to the AI while data gathering and data computation and everything, mainly in advanced imaging techniques. So moving ahead with the next slide, which is like what exactly the AI, as ML is a space exploration program driving innovation into data utilization, which is like we are actually using the optimized resources which we are used to, because there are particular in the processes split into multiple types like primary, secondary, and tertiary. Because of the complexities and everyone is actually occupying the another spectrum or bandwidth of another task, which were as manually with the standard algorithms. By using AI, we are actually optimizing resources use as well as data-driven insights. We can actually process complex data set to actionable insights by enhancing mission planning. That's why. Afterwards, the improved decision making. After considering multiple parameters of that project and the objectives correlation. Sometimes due to the human intervention, we were losing the actual objectives which were needed for while exploration, and therefore lots of extra data. And due to that, the decision making were getting very poor. But due to this AI involvement, we are actually the improved in the decision making, which is like continuously it is self-learning algorithms and self executing according to the same learnings. It is time consuming. So let's move to the next slide. So basically, deep learning applications is like advancing in specific areas like satellite data analysis, which is like deep learning, enhances image recognition, onboard decision making, which we are mentioning earlier, which is like autonomous decision making and execution, getting feedback in terms of the loops and execution the task. Afterwards, the real-time adaptations is like self-learning and execution the task apart from by considering the present scenario of as compared to the given contrast pre-decided predictions which we have given for the our system which we have modeled in the AI. So nextly, in upcoming days, actually, presently we are by looking at the present literatures and understanding its application, we are using huge like swarm intelligence, which is obviously inspired by bees, ants, fish, by nature. And its complex challenges by using this intelligent techniques and algorithms, we are actually dealing and actually executing tasks very exponential manner in terms of because previously due to the lack of this AI inspired algorithms, we were using very traditional, lengthy whole data gathering, huge data. Still, it is AI needs huge amount of data, but apart from that, it is intelligent data and which is most needed data. That's it. So, which I have mentioned earlier regarding the data collection and learning and the decision making by understanding the prerequisite given the rules to that particular system, which are the learning through interaction, which is we call the reinforcement learning. After that, real-time adaptation are getting feedbacks. And with respect to feedbacks, they understand their whole situation and reiterates its whole algorithm in terms of that without changing its own fundamental. After that, from like you can see the reinforcement learning, it is implemented in the India's Chandrayaan 1, which is employed a AI-powered autonomous navigation to orbit the moon and conduct the scientific experiments regarding the flow and resistivity of the air. After the challenges which we are mentioning in the overview, which are like the technical challenges, which are high dimensional data, means data management, basically high computational limits and hardware resilience in the extreme environment. Because everyone understands the high temperature, lowest temperature which we need to space, because it is completely huge variation. After that, data management, which is most needed because the amount of data actually directly proportional to the success of that relatively execution of that particular task or that project or some that subtask. And apart from that, AI and everything, it is accepting globally that it is completely helpful. It is not replacing humans. But apart from that, it is in completely, this domain is also in the development stage. So there are need to lots of rules and regulations are yet to be formed and yet to be delivered globally by understanding by agreeing whole. So there is critical system raises question to access this same kind of software or using same kind of technology at different level and in individual consideration. So moving ahead with the next part, which is like operational limitation, which is like which we are mentioning due at earlier stage while implementing the AI data latency, which we are mentioned, 20 minutes one side, 40 minutes both side. Afterwards, the computation time, the signal relay time, and everything. So it was this data latency we can face while AI deployment in uh, at previous stage. Apart from that, it is self-learning, but still it is limited onboard and training because before boarding, it is training new AI model onboard specific is computationally infeasible because the parameters means actual simulating those all parameters, it is nearly not possible, but major parameters which affect actual objectives of that project, which need still it is limited, and those data is also small relatively. That's why it is limited onboard training, which is one of the limitation while getting trained our actual AI. Afterwards, as we know, age AI, it is not implemented till now. So it is like there is major dependency is on Earth as on our side while execution anything. So rely on Earth-based supposed to update and troubleshooting, which requires another additional time, resources, and ultimately which increases the lead time of execution of that particular project. Afterwards, in space, after understanding the limitation at the Earth's end on Earth, in space it is computational constraint, as we mentioned, limited processing power, energy, and restricted AI functionality. Afterwards, the high dimensionality of data must handle massive, huge size, but due to the size limitation, we need to keep it as an optimum level. But still, it is getting insufficient. So the results which we are expecting more and more in an excellent form, which are getting relatively the lower grade due to the uh, weight and size constraint. Afterwards, main which is like hardware resilience of individual material. Even if the cases and everything sustaining the intense temperature ranges, but inside components need lots of coating, which is still insufficient with related to the uh, succeeding at that environmental conditions. So it is one of the main limitation. And while developing any project, yes, it is very huge task related to the hardware due to the very weather and atmospheric condition. So next are the ethical and legal changes, as we are already discussed. Keep there are no particular form set of rules which are mentioned and which is framed till now. Still, it is in development stage. Many more at fundamental level. It is formed. It is in approval stage. Still, some industries are accepting, some industries are not. But overall, it is like keep every other nations, every other teams, every other organization having their own with their own proofs and records. And there's another trajectory actually there in AI, specifically for having the rule book of like robotics, which we have set of rules for while designing and development of robots. But in AI, it is like very huge and vast. And so understanding the whole major system and considering and means forming the set of rules, it is challenging due to the legal challenge, which are like accountability concerns regarding the liabilities. Next is the privacy and data ownership. Who forms, who proves, everything is challenged. Apart from that, global policy gaps, which is like nation to nation, it is getting worried every time. But it will get wrapped in within one decade maybe. So maybe while dealing with AI, data is used. So data gathering and data processing, and it's for training further systems, for training further algorithms. We need to we need to have various huge amount of data and its management related issue, which is like high volume data, struggles to process the vast amount of data as well as the stores as well. Afterwards, due to the large huge amount of data, and we should use the sub-boiling point algorithms which we are using for the avoid reduce the latency. We can't avoid the latency as it is completely non-linear the parameters with respect to the data. We used to think that latency in the like delivering and receiving and everything, it is depends directly, it should be directly proportional, but by looking after the reiterating the procedures in simulation based softwares, we are facing directly sometimes inversely proportional, sometimes directly proportional. So the amount of data is such that with respect to individual parameters and with respect to individual scenarios, we should understand that the latency of decision making in real time is not linear; it is completely non-linear. And to understand this, afterwards, the third point, which is like data security risk. Data security risk, it's like everyone is gathering their own set of data. Some may need to share in some countries may need to share due to the policies of our space exploration and uh, like ISRO and NASA's. So they are what they are mentioning. You need to share if you are they are allowing you to execute some project. You need to share some set of data, which is the primary source, which is not directly related to the ultimate objective of that specific project and the technology related to them. Apart from whole data, we need to share. So, but while sharing that, there is data security risk while exchanging the data for AI related data, there are many more factors like objectives, parameters, sub primary, secondary, or tertiary level, all complex 27 types, different parameters, which we are presently using domestically as well as globally, uh, because its rules are already set. So that data security rate, data exchange, it is very big issue relatively. So apart from that, next, which we are instead of like next technology, which is IoT, it is like a Internet Space of Things, IST, the piloting connecting space system. Means after understanding the implementation of various smart uh, nature-oriented algorithms, which we have mentioned earlier, swarm optimization and everything, the emerging IoT concepts, which we are satellites, rovers, ground system, enabling seamless communication due to the IoT. Apart from in space mission, IoT facilitate real-time monitoring, coordination, and data exchange, which we are trying to cut down the latency part. But yes, it is there. It will be there. Apart from challenges side that cybersecurity and network scalability remain critical concerns to Internet of Space of Things. So moving ahead to the next slide, which is by blockchain. While communicating the huge data and getting feedback of same to avoid the errors and everything, we need to the secure data transmission. There should not be some traceability while doing the blockchain because it's complete the zero uh, what we are saying zero trace. method which we are using in blockchain, specifically our space mission and defense product. So it is like blockchain ensures secure and tamper-proof data exchange, which will be. It is presently it is an implementation stage at various something like one uh, ESA Swarm mission, which utilizes AI to analyze and process data from constellation of 3 satellites monitoring on Earth's magnetic field. So this afterwards, due to the blockchain, it is already as we are using crypto and everything, it is completely based on the blockchain and black box, which we are afterwards the smart contracts, which already promotes the by the blockchain. Other potential applications are satellite communication, afterward resource allocation and mission coordination. It means real-time monitoring and the sub-stage output delivery. Afterwards, moving at the robotic autonomous system, the autonomous as itself explained, it should take decisions and it should execute that particular set of tasks after understanding the present scenario and by learning the iteratively the whole method, which is increased autonomy. AI allows robots to navigate, perform tasks independently, minimizing human intervention. We are trying to be level zero, but it is not possible. But it is surely less human intervention makes more reliable and more uh, scalable, which we can actually empirically we can derive all the tentative outputs and predict the further results. After that, planetary explorations like rover drone use AI to explore surfaces, identify resources, as well as collect their data. And collaborative robotics, swarm intelligence enables coordinated missions with multiple robots. So by moving that next slide, which is like Mars rover, which we are using by NASA using is like autonomous navigation. After navigation, they are actually understanding the data of this trajectory as well as their own decision making using the AI. These are the major AI contributions in recent projects. So due to using of AI, we are actually satelliting enhancement in terms of AI bandwidth utilization because we were using previously for communication with space shuttles and other equipments and satellites uh, in 2 different bandwidths, which we are manipulating at some stage omni core because due to the single core, they were overlapping some activities, so there was lag between communication. Some signals may get used to hamper due to this two-way communication from omnicore. So due to the AI implementation, we can actually allocate the bandwidth and fluctuate that bandwidth size with respect to the individual side of communication and individual side of data. And there are simultaneous communications, SAR, simultaneous analysis and resemblance, which we can implement by easily due to the AI. Afterwards, the due to the AI integration, Earth observation, imaging techniques, high potential cameras, hyperspectral cameras we can use by getting fewer lesser data relatively as previously due to the use of AI, and we can actually conclude with our potential results. But moving at the actually it is very seems due to the lack of actually less interactive sessions. So it's like conclusion is like AI integration revolutionizing mission efficiency, autonomy, and innovation. But still, actually, all human touch and intuitiveness is most needed because AI is not going to replace any human factor because it is much needed. But just AI is enhancing human uh, scope of work toward a different trajectory to execution this complete AI implementation in space exploration so that humans are will be ready for think about the other spectrum instead of the data gathering execution the task which we can use by we can actually execute with the help of AI. It is more easier for us to understand that it will not. So it is our new frontier, which is intelligence system, unlock the possibilities to deep space exploration and sustainable missions. So here are potential some examples. which we are using from very since 1988. It has started in US, which is like the NASA Mars Curiosity rover. Uses AI-powered autonomous navigation to explore Mars surface and make decisions based on real-time data. Afterward, in European Space Agency, it was something ESA's Rosetta missions. Yes, so it was employed to AI to navigate the orbit comet, providing unprecedented insights into cometary science. Afterwards, that same in 1991, NASA's Deep Space One demonstrated AI-powered autonomous navigation, propulsion, and communication system during its flyby of asteroid Braille and comet Borrelly. Afterwards, ESA Swarm mission, which were executed in 2012 and 13, actually it was delayed, executed, but due to some minor, which we have actually used as a case studies for our upcoming projects to understand that we utilize AI to process the data from the constellation of 3 satellites monitoring Earth magnetic field. They actually took very different parameters and they gathered really good data and tried to conclude with that, but due to the that explosion of that their unit, their whole data lost, and finally they got very related due to the small black box was there, which were the secondary power retrieval plus the primary data gathering source. They got only that, which is nearly around 8 to 9.5%. That's it. Afterwards, and NASA's LADI is like lunar atmospheric and dust environment explorer. Use AI to optimize lunar orbit and conduct scientific experiments related to the atmospheric temperature. Afterwards, India's Chandrayaan-1 employed AI-powered autonomous navigation trajectory to monitor the orbit the moon and conduct scientific experiments. Afterwards, NASA's Kepler Space Telescope uses AI-powered machine learning algorithm to analyze data and identify exoplanet candidates. These are a few examples which we are actually seen and understand its own literature by understanding its own lag and advantage and disadvantages. So presently we are at very as by looking at industrial insights which we are implementing. It's like we are standing at that age. We are developing the microsystem which are needed for the for succeeding a particular projects related to the optical scope of work and optronic scope of work. So hardware preparation of same, which our organization is doing with related to the camera at primary sensing elements and tertiary sensing elements. The computation part, which like actually implementation of AI algorithms, which is like integration in system, which we are directly taking from our other foreign supports and consultancies, which are available at global level and which have already having certification and they are implementing everything on a global set of rules and everything. So let's move ahead with like what will be the future, which is like interplanetary colonization. AI will enable autonomous habitat construction, resource management on Mars and beyond, which is actually doing by the using Mars rovers. And Gen 2 Mars rover actually in development stage, which is some parts manufactured, the molds and everything that intelligent self-healing mold actually our Parasite is developing for this next gen rovers. Afterwards, the human AI collaboration, which is much needed as we discussed earlier regarding the human intuitiveness. It is much more important while uh, executing any project and collaborating with the same. So human AI collaboration, quantum computer integration, it's like competence quantum computing. It will next leap of understanding the execution of specific lots of mission due to its leverage over superior problem solving with relatively less amount of data. So yes, these are the potential references, and apart from that, many more documentaries and literatures of which I have used and my subordinates for producing this uh, overview of this ultimately AI implementation for the exploration of AI enhanced missions in specifically domain related to the computer science and IT. Uh, what we are expecting actually at this level, as we are on very philosophical stage, we should foster industry partnership to actually, as we are Atmanirbhar Bharat, we should collaborate across private and public sector to integrate AI innovation into the space mission. After having excellence from the institution, from technical institutions like the IITs and NIT, ASIS, Bangalore, many other are proportionally contributing towards this goal with the help of the industrial partnership. Afterwards, the by spreading the word with the relative students and research scholars for pursuing their instead of doing regular type of project, we should our initiatives and exchange thoughts, which may sometimes found sometimes difficult to understand by another person, but it is imaginary. But we should actually share with the other our fellow students and as well as our teammates to actually start working on AI implementation and various fields. But in space exploration, it is much needed. Due to that, we can open the very new scope and new spectrum for our India to gain some advantage over other countries. Afterwards, empower future innovators, develop educational programs related to the AI implementation in various domains, specifically to the space and defense. It is much needed because it belongs to very primary stage of involvement, as we can see. So moving ahead, next slide. It is like thank you. It is instead of 1.5 hours due to this session was very brief overview related. It is here my conclusion. Kindly engage with this. Uh, if anyone have, we can have any communicating any questions on anything. You are welcome to. Please kindly ask.
Yes, participants, do you have any questions?
Rane
Yes.
sir,
Hello?
hello
Yes,
Rane
sir.
sir.
Yes, sir.
I have one question.
Yeah, please go
Yes,
ahead, sir.
please.
Uh, Sir, I would like to ask through you to the speaker that he was discussing about the MMPT
Algorithm.
MMPT
Right.
use and how AI can effectively use the solar panel to and the MMPT inverters. So, can he tell something more on the MMPT using AI?
Okay, so by under over there, they were what they have actually used by using the literature of using LVRT, low voltage ride through. Using that, they have actually, by understanding, it's something around like 7 parameters they have used. Uh, with they have interchanged their positions and they have actually generated the algorithm which actually derived the perfect tentative three positions in IV chart with respect to the MPPT basic objectives. And then I will surely share one transcript related to the LVRT MPPT, one written by some Steffi James from NIT. Yes. So that actually that literature served actually whole philosophy as well as the implementation for particularly that energy extraction at the maximum possible efficiency.
But that maximum efficiency will depend on the n number of parameters, sir. So how
Right.
AI is going to utilize for generation of maximum efficiency of that solar panel through the that algorithm?
Understood. I completely understood your question, but with respect to fundamental parameters, apart from uh, this what we can say, the electrical parameters. I can't exactly comment how exactly they derived this whole procedure, as it was introduced an overview. So I introduced that as an example for delivering this. But I'll surely get back to you with the supporting backup literature.
Yes, sir. Yes, sir. Okay, sir.
Thank you.
Thank you. Thank you, sir.
Hello.
Yes.
Yes, Gopinath ji, go ahead.
Hello. Recently, there
Yes.
was a lot of excitement and applause that we could map black holes in 2018 or so. Can you throw some light on that? How we could do that? And,
Will you please re-question that? Will you please actually? I didn't get exactly what should I put light onto. Will you please the black hole and 2018?
No,
I got it.
black holes usually they doesn't emit anything. It absorbs everything, and we couldn't earlier do anything. So recently in 2018, they could map black hole and image it. So how they could do it? Can you throw some light on that?
First of all, one of documentaries I have recently heard in 2021 that they were trying to do some research and related to the, first of all, the identification, the exact 3 point, what we can say, the triangular method, which they were using something like, I was not relating that specific terminology, but they use that method, which is completely based on the pure astrophysics, which is something derived from Dr. Neil. Yes. So they derive by using same that technique. They try to find out the tentative position of the, but still it is in like contradictory means statement. They are saying they have identified with relate by using, they are saying indirect parameters they have sensing, and everyone is means the comments and the interviewers is mentioning and the other astrophysicists are mentioning that tertiary feedbacks and secondary feedbacks are not actually the remarks which they can use for actually identifying that finally this is the position of that specifically black hole or not. But yes, there is studies going on, and yes, it is at, it's like in that stage where they are ready to take a second leap of faith कि this time ho jayega, something like this. But perfectly, you got mentioned something right here. It was 2017 end or something, or first quarter of 2018, right?
So my question is that this physics-inspired machine learning we are using for space exploration. In this standard model, it is still not fitting. That is, we could not identify 67% of a dark energy or whatever it is, and
73 point means you mentioned
so,
nearly same, 73%. Yes, it is something.
And the Einstein model or whatever it is not fitting into the primary Big Bang model. To when you go to the primary black holes or something like that, it is expansion is going much faster than that. So then how how we are implementing for finding out exoplanets, and also what is which algorithm?
Finding exoplanets using standard algorithm. Actually, the NASA's one program is the EUPTO program is there, which they are using. They are trying to, but as per the standard norms and condition, they are not they are not allowing due to the they are actually what they are doing is similar type of but different parameters they are combining for the simplicity and the linearity. To adapt linearity in any project, any mission or something, which we are actually cheating with that ultimate objectives. So they are facing that they are not allowing to do or execution related to that, but still they are trying to find out the loophole in the system so that they can actually commence the journey for finding this exoplanets, and afterwards the boundary points of that black hole, and the imaginary by using imaginary points they are trying to find the trajectory to boil down the communication of not exactly their own enhancing but the other countries communication, so that they can use maximum bandwidth of that specifically their communication signal and everything.
Where are we in this whole scenario about India? Can you just comment?
Okay. With respect to India, I can't actually comment because till now the philosophical base, the material, and the discoveries, or the with respect to industrial insights, which is the final and what we can say that the data which we get, it is nearly zero, or understood. Like many organizations, there are many organizations, the government organization, but obvious they are growing huge in this direction. AI implementation in space exploration and the AI enhanced missions. But at present, the scenario is that they are sharing very restricted data. Even they are not giving any fuzzy signal that in zero, black or white. Yeah, we are doing that or we are not doing that because the individual secrecy protocols and individuals. So we can't actually commit with respect to India. At means with this related to this, we are doing or not. You are understanding? Everyone is saying philosophically, हाँ ये कर सकते, ये कर रहे, but full proof just after something with some backing, no one is giving such kind of input.
Okay, thank you.
Yeah, it was very nice discussion. Any other questions from the participants?
Sir, I want to ask one question, sir.
Yeah, please go ahead.
Yes, please.
Yeah, actually, whatever the explorations we have seen in the past 50, 60 years, so it is based on the countries, those are the countries' exploration. So whatever the AI tool we are using, is the data is, we have to siphon the data, or it is being shared to us, or what kind of thing is that? Matlab,
Okay, I understand your question. Means I'll just rephrase it for a better understanding. It's that till now, from long many years, means from 2 decades, we can comment on that because the 2 decades of which we are observing that actual missions and projects are actually ongoing with related to the AI because it is globally accepting because it is very advantageous. So related to the data gathered with respect to the individual projects or individual missions and individual objectives, it is mandatory to share secondary and tertiary form of data related to that mission. It is means as per the norms and conditions set presently by the that organization for related to the space mission and AI implementation, because it is completely different spectrum of the set of rules, setting rules and everything, because it is changing and it is challenging itself only day by day. So yes, there are, but what they are facing actually issue related to the data sharing between the organization between the countries is like that. Uh, every human means every organization is facing a in partial matter also they have to, because of that norms they have to share the data to that specific set of countries or specific set of organization. So many, almost 35 to 38% organization are like, "Hey, we don't want to fall into this category of this." because we are deriving data and collecting it, storing it, and at very huge cost. So by using their means primary source only, it is very difficult to share. So there are many contradictions out there. But yes, uh, AI it is what about the actually data gathering, learning algorithms, and everything. So yes, interchangeability afterwards, the data sharing, it will be compulsory, and it is compulsory in some manner presently, but in future, yes, it will be in major proportion.
Okay, thank you, sir.
Which
So, question, sir. In the last slide, you have said that we can have a education program with the academicians. So, is there any plan of Paras to have some academic MOUs to the universities like? Or
First of all, yes, actually, not at present, but in future, within like after in between 3 to 4, after 3 to 4 quarters, they will be trying to explore something uh, related to this specific AI oriented for not exactly the final implementation, but the earlier stage of execution, algorithm development. They are willing to, and they will be going to uh, getting connected with this such kind of institution, renowned institution, to gain more academically excellence in an institutional level, as well as to get more philosophical and fundamental backing on specific project development and execution level, which will surely help with respect to the organization for Paras.
okay, sir. Thank you. Maybe we can have a this MOU after 4 to 4 quarters. I will
Sure.
just enter. Okay, thank you,
Yes,
sir.
because yes,
Yeah.
because presently what is happening no in many institution, and what we can say is that interdisciplinary approach with related to, because what we are doing is taking with our own set of field only, and our real-time projects and everything are very interdisciplined. They are demanding interdiscipline thinking of nature, means nature of thinking, again actually hardware implementation or something. What we are doing is just means in on institutional level while doing projects, uh, many more people are more focusing to getting conclusion with some kind of hardware, with some basic philosophy, which can be more based on literatures and everything, but it is not ultimately helping in our industrial insights. Because even I once in a while I was in so in engineering field, in engineering college for doing my bachelor's. So we are facing this issue, but this the program which I am currently enrolled in, it is like a mini PhD, you can call it, by the Symbiosis. They are actually carrying out this mini PhD program, means MTech by engineering, means by research. It is 3 years program by the Symbiosis. They are all are industrial. It is basic eligibility criteria is that you should be working in specific domain for the past of 3 to 4 years, and afterwards you will be eligible for this program. So something like this we should accommodate, and we should for our educational as well as this industrial partnership.
Okay, sir. Thank you, sir. Sabzan.
Thank you, Dr. Arun.
Oh, thank you, sir. Thank you very much.
Yes.
Yes. Any other questions or interactions that you want to make with the speaker? Yeah, last call. Suvarna Patil ma'am? No? Okay. Chalo. So let's wind up today's session. Yeah, so let me present the vote of thanks. So on behalf of the whole organizing team, I extend my heartfelt gratitude to Mr. Vaibhav Mali sir for delivering such an insightful and enriching session today. You started with the introduction to AI in space missions, and then land upon like discussing the importance of intelligent space systems, to diving deep into cutting edge topics like spacecraft health monitoring, autonomous navigation systems, and remote sensing enhancements. So your session has been a testament to your expertise in this field. We particularly appreciated how you address the challenges and limitations in this field. The questions asked by Professor Zavade and Mr. Gopinath and the other guy. So thank you so much for taking the time to share your knowledge and experiences with us. Your contribution today has undoubtedly inspired many of us to explore this field. Thank you. Thank you so much, sir.
Thank you.
Yeah. Participants, I'm posting the feedback and attendance links in the WhatsApp group. Please fill them. As the next session was scheduled at 7:30, I just now talked with the second session speaker. So he will be available at 7:30 only. So we will start the next session, second session, on the scheduled time itself at 7:30 p.m. So I request everyone to please fill the attendance and feedback and get back at 7:25. Okay, thank you.
Thank you.